So I'm just going to do two types of factoring, two more types of factoring in this lecture. We already learned how to factor a trinomial that has this type of characteristic. And I want you to pay attention that the first example, we have a one coefficient, x to the power 2 plus 10x plus 24. So three terms, we have a degree of 2. This one is half of 2 is 1, and this one is a constant. And it's very important that you pay attention that this coefficient is 1. And we said if we have such a problem, then we say what are the factors of 24. Since we have a positive here and a positive here, we only think of positive factors. So positive 1 times positive 24, or 2 times 12, or 3 times 4. And what else? To get 24, not 3 times 4, I'm sorry, 3 times 8, or 4 times 6. So these are the possibilities, right? If I multiply any of these two, I get 24. And then I add them to see which one is going to give me 10. 24 and 1 is 25. 12 and 2 is 14. 8 and 3 is 11. 6 and 4 is 10. So these are the factors we choose. Next, we are going to open up two parentheses and put x inside each parentheses. So we open up two parentheses, break the x to the power 2. This x to the power 2 is written as x times x. 24 is written as positive 4 and positive 6. We can put positive 6 first and positive 4 inside the other parentheses, doesn't matter. Then, what is it called? So we are done. This is how we factor this polynomial. So the factor for x to the power 2 plus 10x plus 24 is x plus 4 times x plus 6. If I multiply these two parentheses term by term, combine like terms, this is what I get. We want to factor this one. So then I don't have a 1 as a coefficient of x to the power 2. Then what I do is I say, is there a greatest common factor of 2? So I factor a 2. When I factor a 2, remember, 2 is the greatest common factor. And the way we do this is we write this as 2xx. 6 is 2 times 3 times x, plus 4 is 2 times 2. As you see, every single term has a 2 as a common factor. X is not a common factor because this term does not have an x. So 2 is the greatest common factor. So I write the greatest common factor 2, open up a parentheses, and then the leftovers go inside the parentheses. From the first term, x times x is x to the power 2. From the second one, we are left with 3 and x. From the last term, we have 2. Again, we have a trinomial. The coefficient of x to the power 2 is 1. So we are going to factor this one. We say 2 can be written as 1 times 2. We don't think of negative 1 times negative 2 because all the terms are positive. So this is not a possibility. 1 times 2 is 2, and 1 plus 2 is 3. So we are able to factor this. So the factors for x squared plus 3x plus 2 is x and x, positive 1 and positive 2. And then we carry the 2. So the factors for this polynomial is right here. They're the same thing. They're equal to each other. In other words, if I multiply all the three factors, this is what I would get. So we have done both problems in the previous lectures. Now I'm going to introduce another type of problem to you. You might think that this problem is similar to this one. The only thing is, there is no greatest common factor here. 2 was the greatest common factor, but here 2 is not the greatest common factor because 11 is not divisible by 2, or you cannot write 11 as a factor of 2 and something else. So there is no greatest common factor, and it is different than this problem because this one has a 1 coefficient and we don't have a 1 coefficient here. So you cannot say, let me find 2 factors of 5, which is 1 and 5, and factor this problem. It doesn't work that way, okay? So when you do have a coefficient other than 1, and it cannot be factored out, then we are going to learn another technique to factor this type of polynomials. So what you do is you have to do a little bit of work, and then you do the same thing as above. You're going to multiply this 2 by this 5. Okay, that's the first step. So if the coefficient of x is not 1, and that coefficient cannot be factored out like this problem, then you multiply 2 and this 5, okay? You multiply 2 by 5, and you get 10. And you go ahead and you change this 5 to 10. And you change that 2 to 1. So these are the things you do. You change the 2 to 1, you change 5 to 10, and 10 is coming from 2 times 5. Again, you have to make sure there is no greatest common factor. That means this 2 is not a common factor, or whatever number you have here. It doesn't have to be 2, it could be 3. It's not a common factor. And if that is the case, then you multiply 2 by this number, whatever that number is, and you replace that number by the new number, and you replace that 2 by 1. Then you try to factor this using the technique you just learned. You say, what 2 numbers to multiply to get positive 10? And this is positive 11. So don't look at negative 1, negative 10, negative 2, negative 5. Only stick with positive numbers. 1 times 10 is 10. Let me add them. So if I get what I need, I don't go any further. 1 and 10 is 11. So I stop here. So I open up the 2 parentheses. I put x in each parentheses. Then I put 1 and 10, which is 1 is positive. I put plus 1. 10 is positive. I put plus 10. You're not done. You found the factor for this problem, but this is your problem. So how do you go back to the other problem? So I made a trick. I multiplied 2 by 5, so I have a 1 here. So I could use the technique that we just learned. So I factored this problem, and this is not the original problem. So for accommodating, what I did to get the answer to the initial problem, I divide each factor by this number, whatever this number is. In this case, it's 2. I divide the factors that I found by 2. If I can reduce, I reduce, like 10 and 2 can be reduced, and I get 5 over 1. 1 and 2 cannot be reduced. I leave it alone. Last move is you put the 2 here and you put this 1 here. So you get 2x plus 1. And this is 1x plus 5. So these are the steps you have to remember. You have to remember when this is not this number here. is not a 1 and is not factored out, multiply it by this number, replace the last term by the new number, replace the coefficient of the first term by 1. You know how to factor this problem, factor it, divide each factor by this number, and then reduce and put the denominator for the factors, make them the coefficient of x. When you have 1x, you don't need to put a 1 here. You could simply leave it as x. So if you multiply these two, that's what you get. I'm just going to show you if I multiply 2x plus 1 by x plus 5, I'm going to get my original expression. 2x times x is 2x to the power 2. 2x times 5 is 10x. Then I multiply 1 by x. 1 times x is 1x. Then I multiply 1 by 5. 1 times 5 is 5. And since all the terms are positive, I just get plus signs. Then I look for like terms. 2x to the power 2 doesn't have any like terms. Positive 10x and positive 1x, they're like terms, so I can combine them. I have 10x's and 1x. That gives me 11x's plus 5. So do you see, you get that? So we are going to practice a few more. Next problem, let me erase this work here. And I highly recommend that you guys check your work to improve your algebra. If you improve your algebra, everything from now on, your math 1414, math 2412, or calculus class will become so easy for you. So anyways, I see that the coefficient of x to the power 2 is not 1, and 3 is not a common factor. In other words, 7 is not divisible by 3, or 2 is not divisible by 3. So what do? I multiply these two numbers. I multiply 3 by 2 and I get 6. I replace 2 by 6. And I replace 3 by 1. And then I say two numbers to multiply to get 6. Since all the terms are positive, the factors must be positive. So I don't think of any negative factors. If I add 2 and 3, I get 5. This number is not 5, so 2 and 3 are not the correct choice. How about 1 and 6? 1 times 6 is 6, and 1 plus 6 is 7. So 1 and 6 are the factors. Let me erase these so I have room. Open up two parentheses, put x inside each parentheses, and put positive 1 and positive 6. 1 times 6 is 6, 1 and 6 is 7. Then I have to remember this was not my expression. This is my expression. So how do I get back to that? How do I find the factors for this problem? I divide each factor by 3 and reduce. 6 and 3 are reduced. I get 2 and 1. 1 and 3 cannot be reduced. I move 3 over here. And if you want, you can move 1 here or just ignore when the denominator is 1. And this is what you get. Again, you don't need to write the 1. This is your answer. Let's look at another problem. I have a 5 here, and I have a 6 here. 5 is not a greatest common factor, so I multiply 5 by 6, I get 30. I put 30 here, and I change this number to 1. So I get 1x to the power 2 minus 7x negative 30. So I want to factor 30. 30 is made out of 1 times 30, but I have a negative here and a negative here. So I know one of the factors must be negative. So 1 and 30 doesn't work because if I add them, I get 29. If I make this one negative and this one positive, doesn't work because if I add them, I get negative 29. What other factors are there for 30? For negative 30, I can put also negative 2 and 15. That gives me negative 30. But when I add them, I end up subtracting, I get 13, and this is negative 7. So that doesn't work. If I change this one to negative and this one to positive, since one number is negative, one number is positive, I add them, I get negative 13, or you end up subtracting and you get negative 13, so it doesn't work. For 30, I can also look at 3 times 10, right? So you start with 1 times 30, 2 times 15, 3 times 10, 5 times 6, and then you change the sign because this is negative. You put a negative here, you test it. Then you make that negative, you test it. Then you make this one negative and this one positive. Then you make this one positive, this one negative, negative, positive, and you keep testing until you get the right factors. So that's what I'm doing right now. So the other ones are negative 10 and positive 3. Since one number is negative, one number is positive, when I add, I end up subtracting them. Then I have 10 take away 3 is 7, but since 10 is negative, I get negative 7. So this is negative 10 and this one is positive 3. Those are the correct factors. So let me go ahead, open up 2 parentheses. Put positive 3 and a negative 10. And then the next move is to remember to divide by that 5. 3 and 5 cannot be reduced, but 10 and 5 are reduced. 5 moves here. So I get 5x plus 3. If 1 moves here, I get x minus 2. And that is your answer. For the next problem, I see that this is not a 1, but then I say, do I have a greatest common factor? No matter what kind of trinomial factoring you're doing, whether this first one, the first one, the second one, the third type, make sure your leading term is not negative. So do you see I have a negative leading term, and I see all these numbers are divisible by 2. So negative 2 is my greatest common factor. And I can write this as negative 2 times 4, x and x. I can write this as negative 2 times 4x, and I can write this positive as negative 2 times negative 3, because negative times negative is positive. And as a matter of fact, how about if I do this? Every time, you want to factor a negative, you see I have a negative here, so I leave that as a negative, and I write 8 as negative 2 times negative 4. So this way you don't mess up your negatives. So 6 is negative 2 times negative 3. 8 is negative 2 times negative 4. But don't forget you have a negative here too. And look at your greatest common factor. Negative 2 is your greatest common factor. Write it out. Negative 2. Open up a parentheses. You have 4x to the power 2. You have a negative and negative 4. That makes that positive 4x. And here you factor a negative 2. You're left with positive negative becomes negative 3. So negative and negative becomes positive. This positive and negative becomes negative. So this is what you have. Even though when we factor the negative 2, again, our coefficient here is a 4. So if I want to factor inside the parentheses, I have to multiply 4 by 3, and the answer is 12. I change 3 to 12. Do you see I don't change the sign? I leave the sign alone. So I write this piece as x to the power 2. I change 4 to 1 plus 4x 4 times 3 is 12. I leave that sign alone. I just deal with the numbers. I know how to factor 12. I want to multiply two numbers to give me negative 12. So one number has to be negative, one number has to be positive. And then when I add them, I get 4. So the two numbers are 6 and negative 2. 6 times negative 2 is negative 12. 6 plus minus 2, you end up subtracting and you get positive 4. So those are my factors. I open up the two parentheses, put x inside each, positive 6 and negative 2. Those are my factors. You cannot forget this step, otherwise your answer will be incorrect. You divide both by 4. 6 divided by 4 is 3 over 2. You must reduce these fractions, otherwise your answer is incorrect. If you forget to factor the negative 2, your answer will be incorrect. If you forget to divide by this 4, the answers you get is incorrect. So you have to remember all the steps. So anyways, you get 3 over 2. This 2 becomes a coefficient plus that 3 on the numerator. 2 and 4 are reduced, you get 1 and 2. 2 goes to 2 one time, 2 goes to 4 two times, so you get 1 over 2, and that 2 goes here. And we carry the negative 2. And that is our answer. If you multiply these two parentheses and then distribute the negative 2, you are going to get that. And I'm going to show you just, so you see I got 2x plus 3, 2x minus 1, and I had a negative 2, right? So let me show you. If I multiply these two together, I will get, that's plus 8 minus 8. I want to show you that these two sides are equal to each other. So how do I multiply? There are multiple ways to multiply. You can multiply negative 2 by these two only. Don't multiply negative 2 by the first parentheses and by the second parentheses. You only multiply it by one of the parentheses. Just like if you have 2 times 3 times 4, you multiply 2 and 3, you get 6, and then you multiply 6 and 4. So when you're multiplying three factors, you multiply negative 2 by the second factor, and then you're done with negative 2. I have seen students make a mistake, multiply negative 2 by 2x, by 3, and then multiply negative 2 by 2x and minus 1, which is incorrect. So you multiply it by the first parentheses only. Negative 2 times 2 is negative 4x. Negative 2 times positive 3 is negative 6. So you're done with multiplying these two. Just like you're multiplying 2 by 3 and you're done, you get 6. So you're done with these two. And then you multiply the result by the third factor, which is 2x minus 5. So you multiply negative 4x by 2x. You get negative 4 times 2 is negative 8. X times x is x to the power 2. Then you put a plus sign. Negative 4 times negative 1. Negative 4x times negative 1. Negative times negative is positive. 4 times 1 is 4x. Plus sign. So there's a parenthesis here. We are done multiplying negative 4x by both of them. Now we go after negative 6 and multiply it by both of them. Negative 6 times positive 2. Negative times positive is negative. 6 times 2 is 12. So this becomes negative 12x. Then I multiply negative 6 by negative 1. I get positive 12. Positive 6. Then I'm going to look for like terms. Positive 4 and minus 12x are like terms. This is like saying I borrowed 12 x's. I returned 4 of those. How many do I owe? Because one number is positive, one number is negative. You end up subtracting 4 from 12. 12 is bigger and 12 is negative. So the answer is minus 8x plus 6. That's all I wanted to show you, that these two are equal to each other. And you should always check your work. Not only it improves your algebra, but if you have made a mistake, you forgot a step, you see it and you correct it. Okay, so very, very crucial that you check your work all the time. Now there's another kind of factoring. We call them group factoring. But to start off the group factoring, I have given you 2 examples. Do you see I have x plus 3 for the first term? X plus 3 is a factor of x, and x plus 3 is a factor of negative 2. So if you look at the 2 terms, I have this term and this term. They both have this x plus 3 as a common factor. So I'm going to factor x plus 3. Then I open up a parentheses and I dump the leftovers. So this is here. Then I'm left with x. X plus 3 is here. I'm left with negative 2. I want you to go over this multiple times and make sure you see what has happened, because it is a little bit different than the previous problems. I don't have like one thing like an x or 2x as a common factor. This time my common factor is a parentheses. My common factor is x plus 3. I have x plus 3 for both terms. That is my common factor. So it's the same for the second problem. For this problem, this parentheses, x to the power 2 plus 2 is the common factor. So I'm going to write my common factor, which is x to the power 2 plus 2. Open up a parentheses, then drop all the leftovers, which is x plus 5. So I factored this polynomial that is not like the other polynomials that you have seen before. So I went through that example because I wanted to show you. I have one more example. So let me just do this one more time. In this case, I have x minus 1 as a common factor. I only have 2 terms. This is one term. This is another term. Both of them have a common factor, x minus 1. Both of them have a common factor, x minus 1. So I put the common factor here. I open up a parentheses. Then I have an x to the power 2. And then I have a negative 4. But then I look at x squared minus 4. And I say, well, I can factor this. I stopped at this problem. I stopped here because I could not factor x squared plus 2 because this is a positive sign here. And x plus 5 cannot be factored. So I stopped here. And for the first problem here, I also stopped here because neither one of these parentheses are factorable. But when I come to the second problem, I see that, what is it called? Sorry, I just want to erase a few things because there's just so many writing here. My iPad is going to freeze. Okay, so for this problem, when I factor, I realize that one of the parentheses can be factored further. So I should factor x squared minus 4, which is the difference of 2 squares. 4 can be written as the square root of 4 is 2, and a square root of x squared is x. So I can write this as x minus 2, x plus 2. And then I have the x minus 1. So this is factored completely. So I started with this, and the factors are x minus 1, x minus 2, x plus 3. I mean x plus 2, I am sorry. So these are my factors. Now that you have become familiar that sometimes your factor, your greatest common factor, is something that is a parentheses, I want to go over group factoring with you. So how does group factoring work? I have x cubed plus 2x to the power 2 minus 9x minus 18. I have four terms. So when you have four terms, you should think of group factoring. You pair up the first two and you pair up the last two. You say, what is the common factor for the first two? So look, I have x and x and x plus 2x times x. I look for the greatest common factor for these two. I see that they both have that x to the power 2 as a common factor. xx gives me x to the power 2. The leftovers are x plus 2. Then I say, how about this? How about negative 9x and negative 18? What is the common factor for those two? I see negative 18 is made out of negative 3 times 3. Negative 18 can be written as negative 3 times 6. I could write negative 18 as negative 2 times 9. So let me, as a matter of fact, do that. That's even better, right? Why did I change it? Because I want to find the greatest common factor. 3 is a common factor, but it's better to write it as negative 9 times 1 and negative 9 times 2. So I'm looking for the greatest common factor between those two. I see minus 9 is the greatest common factor. So I put a minus 9. Do you see I connect these two to these two with this negative sign? They both have a negative 9 as a greatest common factor. You have to look at these two. You don't want to have a negative as a leading term, so I factor a negative 9. Then I'm left with 1x. When I have a 1x, I just leave it as x. I factor this negative 9. I'm left with negative 2x. Oops, sorry, I don't know where I got that x from. There's no x. So the greatest common factor is negative 2. So negative 9x is negative 9 times 1 times x. And then 18 is negative 9 times 2, because negative 9 times 2 is going to be negative 18. And again, I am making a mistake here. I'm just going to do the following. This is a minus. I write 18 as 9 times 2. When I factor at the common factor negative 9, I get 1x, and then I get plus 2, because the negative 9 is here. Why did I do all this playing around with this piece? Because I wanted to factor this in such a way that both terms have the same common factor. Now x plus 2 is the common factor of these two. I'm going to factor x plus 2, which is common factor between them. And then I'm left with x to the power 2 minus 9, x to the power 2 from the first term, and negative 9 from the second term. And x to the power 2 minus 9 itself can be written as x plus 3x minus 3. Because the square root of 9 is 3. So that is the difference of two squares. You can factor it one more time, and this is what we get. So this is the answer to this problem. Oops. This problem has the following factors. Now, that I have factor, let's go over the next problem, practice. I look for the greatest common factor from the first two, and then greatest common factor from the second two. So the first two is x, 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 plus 7x and x. By this time, I'm hoping that you have become, you have a mastery that you can find the greatest common factor is x to the power 2, and you don't have to go through these steps. But if you need help or you need more, you need further information, I'm just breaking everything into little pieces. So I have x to the power 2 as the greatest common factor. X times x is x to the power 2. The leftover is x, and the leftover from the second term is 7. Then I look for the greatest common factor between these two. Do you see the leading term between these two is -1? So I can write it as -1x. I can write this as -1 times 7. So then I see that the greatest common factor for these two is -1. And you have to make sure you connect this first term with a negative or a positive sign to the second pair. So I put a -1, the leftovers are x, and the leftover is a positive 7. So you don't just put x and 7. It is always plus or minus. So then I look at the new ones and I say, what is the common factor here? I see x plus 7, and x plus 7 is the common factor. So I put x plus 7 as the common factor. I get the leftover is x to the power 2 minus 1. Sometimes you cannot factor the parentheses, like I cannot factor x plus 7. And then in this case, I can factor x squared minus 1. I have the difference of two squares. The square root of 1 is 1. So I write it as x minus 1 and x plus 1. And that is my final answer. The last problem again, I'm going to look for the greatest common factor between the first two and then between the last two. The greatest common factor is 4x to the power 2. I'm just going a little bit faster. If you break everything, you see that the greatest common factor between these two is 4x squared. If I take 4 and 2 of these x's, I'm left with 1x. If I factor, and then I have the negative, if I factor a 4 from here and the x to the power 2, I'm left with a 3. Then I go to these two. The common factor between those two is -1. So do you see the leading term is -1? If I factor in -1 from the first term, I'm left with positive x. I can write 3 as -1 times -3. So when I factor in -1, I'm left with -3. You always want to do something so that these two parentheses, the new parentheses, are identical. So sometimes you have to factor a -1, sometimes you have to factor a positive 1 so that these two are the same. Because now that is your greatest common factor. X minus 3 is your greatest common factor. Open up the parentheses, you get 4x to the power 2 minus 1. All the examples I have created so far, they all have something so that one of the parentheses is factorable further, but that's not always the case. Like x minus 3 cannot be factored anymore. But 4x squared minus 1 is the difference of two squares, so it can be factored. So square root of 4x to the power 2 is 2x, and the square root of 1 is 1. So I'm just going to have 2x plus 1 and 2x minus 1. So these are your factors. And that is the end of the lecture.